In this episode, we talk about the Chandrayaan 3 rover and lander, which had been put on hibernation mode by the ISRO. We also talk about an upcoming framework in India which will provide climate services and information. But first, we talk about the Nobel Prize in Chemistry. Hi, I'm Rahel Philipose, and you are listening to Three Things, the Indian Express News Show. Last week, the 2023 Nobel Prize in Chemistry was awarded to three scientists, Mungi Bawendi, Louis Bruce, and Alexei Ekimov, for their pioneering work on quantum dots, which sparked a revolution in nanotechnology. When we spoke to the Indian Express's Amitabh Sinha, he told us that these quantum dots are actually nanoparticles.
Nanoparticles are basically very small particles. The reason they are called nano is because they fall in the nano dimensions, right? And this is, we are talking about, a billionth of a meter or a millionth of a millimeter. So thousands and 10,000 of times smaller in dimension than the width of a human hair or a sheet of paper. Basically very, very small particles. So anything in the range of, say, 1 nanometers, or 10 or 20 nanometers, or 100 nanometers would be called nanoparticles.
Now, to help us understand the significance of these nanoparticles, Amitabh begins by telling us one of the fundamentals of chemistry, that any physical or chemical property of an element is determined by the number of electrons and free electrons it has in its atom.
How hard it would be, how reactive it would be, what elements would it react with, how would it interact with the outside environment, how would it react with other materials, those kind of. So all these properties are determined by the number of electrons that are there in the atom of any element.
And he says because atoms are all the same, it doesn't matter how big or small a piece of an element is in its pure form. Its properties will remain the same.
So, 1 gram of gold, for example, would behave in exactly the same way as 1 kg of gold bar.
Now, this is pretty basic chemistry, and most of us are already aware of it. However, about 40 years ago, scientists made a startling discovery. They found out that nanoparticles exhibit different behaviors and properties compared to their larger counterparts of the same element. For example, a nanoparticle of gold will demonstrate a different behavior than 1 gram of gold.
So, even though the discovery was made then, there was a theoretical prediction. People knew that this was likely to be the case because the quantum effects become evident at that scale. And when I mention quantum effects, it's basically, our listeners would also be aware, very, very small particles, actually their motion and their behavior is governed by what is known as quantum theory in physics. And that behavior is very, very different. Different as in, it's also very counterintuitive. It's not commonsensical at all. So atoms, electrons, protons, particles at that scale, which are even smaller than nanoscale, they behave in very different ways. Not the kind of behavior that we expect of larger things. Say a ball, for example. We expect the ball to behave in a certain way if we do something to it. But these small particles behave in very, very different ways. So nanoparticles at that scale as well, some of the quantum effects become evident, and that is why the behavior is slightly different. And this was theorized when the quantum theory was developed in the first half of the last century, between 1910s and 1950s. It was theorized that there would be a change in behavior if the particles were reduced to very small size in the nanoscale. But nobody had seen it yet. And the first people to show it, to experimentally show it, were these three people who have been given the Nobel Prize in Chemistry last week.
And Amitabh explains that the work of these three Nobel laureates has shown that it is possible to tweak the properties of nanoparticles and induce a desired behavior from them. And the three scientists employed light to test this theory.
As you would know, every particle, the color that we see is because of that material's ability to reflect and absorb certain kinds of light, lights of different kinds of different wavelengths. And again, that is a property of that material. So, a big or a small part of that material would behave in a similar way. But when you go to the nanoscale, their ability to interact with light also changes. So, a nanoparticle of 1 element might be reflecting and absorbing light in a very different way than a larger piece of that same element, because of which, the color, it would acquire different colors than the color that you would see of larger particle of the same element. This is what these guys were experimenting with.
Now, Amitabh says that the results of these experiments, which enable us to manipulate nanoparticles, have been applied in modern technologies, including those used in television screens and the field of medicine.
In the kind of ways that this technology can be used in medical appliances, medical devices, also in delivery of medical therapeutics. So some of those applications are there in the medical field. Also in different research areas, in different scientific research areas, including in physics and chemistry, also in biology. So it has opened a lot of new research areas, a lot of new applications, because you are able to tweak the properties of these elements depending on their size.
And next we talk about Chandrayaan 3. As many of you might recall, India's lunar mission Chandrayaan 3 lifted off from the Satish Dhawan Space Center in Sriharikota on the 14th of July. And just over a month later, on the 23rd of August, it successfully made a soft landing on the southern region of the moon. And by accomplishing this, India became the first country to land on the moon's south pole and only the fourth country to achieve a soft lunar landing. Now, after the landing, a lander named Vikram and a rover named Pragyan carried out their mission for a few days. And then last month, the ISRO decided to place the lander and rover into hibernation mode with the intention of reactivating them later. But despite their efforts over the past few weeks, ISRO has not been able to revive them. To know what that means, my colleague Utsa Sarmin speaks to the Indian Express's Anonna Dutt in this segment.
So Anonna, can you first remind our listeners about the data that had been collected by the Chandrayaan 3 rover after it landed on the lunar surface?
So basically the lander and rover have been collecting different types of data, looking mainly at the mineral composition of the surface of the moon, the plasma that is over the surface of the moon, and it is also most importantly looking for these water and hydroxyl molecules. Then there are also some experiments which are looking at moonquakes that happen. So all of this data is being recorded by the instruments on the lander and rover.
Right, and after a few days of landing on the moon, the ISRO had decided to put the lander and rover on hibernation mode. Could you tell us why did they decide to do so?
So basically they are going a step further with this experiment. So the lander and rover initially were meant to work only for approximately 14 Earth days, which is one lunar day. So the entire thing works with the help of solar energy. And we had to complete all the scientific experiments in this time. However, ISRO also decided to put in like a add-on experiment, so to say, where they are looking at putting the lander and rover to sleep and then seeing whether after a very cold night where temperatures can, fall to over minus 100 degrees Celsius. So they are looking at whether they can wake up the lander and rover and can these instruments still function after this period. So this is an additional science coming from the mission. We already have all the scientific data that was supposed to be gathered.
And Anonna, we understand that at that time, there were some concerns over whether the rover and lander would wake up again or not, right?
So yes, our mission actually initially was never planned for surviving the lunar night, and that is because of the very challenging temperatures that we see on lunar surfaces. So even at equator, the temperature differences can be from positive 120 Celsius to minus 130 Celsius. So it's a huge variation. And from what I have learned is ISRO usually tests its space instruments to about 70 to 80 degrees Celsius and negative 70 to 80 degrees Celsius, which is what they have done with Chandrayaan as well. So we did not know whether it could survive this extreme cold temperature. And there are landers of other countries which do, sleep through the night and then again function when it's lunar dawn. But they usually carry these radioactive heating elements with them so as to keep the electronics working. So it was never part of our plan, so to say, that we'll, put the lander over to sleep and wake them up. But it was an additional thing that ISRO decided that since it is already there, let us try out and see whether the instrumentation can survive the night and then again, wake up in the morning.
And can you tell us what all ISRO did before putting them in hibernation mode?
So even before putting the lander and rover to sleep, ISRO actually attempted another innovative experiment, again not part of the mission objectives, but something additional, which is the HOP experiment, where basically the onboard propulsion system was started. The lander lifted off slightly and moved like 30-40 centimeters and then again landed upright. I mean, we might think, what is the importance of, the lander hopping on the moon? The thing is, this is a demonstration for future missions when we do, say, a sample return mission or a human mission in the future for the moon, to demonstrate that, yes, our lander is not only capable of landing on the surface, but it can also take off from the surface. So this is like, a pre-experiment, and since our lander was already there and since it was going to be put to sleep, ISRO decided that they would go ahead and do this experiment. Now for hibernation, so the communication channels were kept open for the lander rover and their solar panels were faced towards where the sunrise would happen initially. So they were placed in a way that immediately once the sunrise happens over the region, it would fall on the solar panels and everything would start working. And most of the systems on the lander rover were switched off, but some sensors were left on to decide on its own whether the temperature, so whether it had enough battery power, whether the sunlight was at a good angle, whether, the temperatures had risen enough before the other systems would wake up. So that was the plan.
Right, and Anonna, as we know now, that it did not go according to the plan. So what did ISRO do to revive them?
So as I said, the waking up process per se was not something that ISRO would control from here. The machine had been given autonomous instructions that it could wake itself up when the conditions were right. The thing is, we haven't heard from the lander rover since. So ISRO has been trying to communicate with the lander rover since the second dawn happened over the region, but we haven't received any signal yet. And from what we've heard from scientists and the chairperson, we are likely to keep trying to establish that communication. But even when we were attempting this whole thing, the scientists said that it's, a miracle. It is more like, you have 1% charge on your battery, you switch to a power saver mode and you're waiting for the cord to come in. It might come in time to recharge your phone or it might not. So ISRO will again attempt to see whether it wakes up, but it would be a miracle.
And could you tell us what happens if the lander and the rover never wake up?
We will have an ambassador on the moon. We have landed on the moon. We are the fourth country to land on the moon. And we are the first country to land on the South Pole, of course, after that tragic incident with the Russian Luna 25 mission. But I mean, we've already achieved all the objectives of the mission. So if it never wakes up, that's fine. We have all the scientific data that it was supposed to gather. We have successfully soft landed on the moon. We have successfully soft landed on the South Pole of the moon. So our mission objectives so far are already complete.
And in the end, we talk about an upcoming framework on long-term climate data. India is set to launch its maiden national level framework aimed at providing climate services and information. This initiative, known as the National Framework for Climate Services, is being led by the India Meteorological Department. According to Anjali Marar, who is the Science Communication Officer with Raman Research Institute and writes on science and climate change for the paper, the new framework will essentially serve as a comprehensive resource for climate researchers, stakeholders, and communities seeking climate-related information and services. Here, Anjali breaks down the primary objective of the new framework, which is currently still in nascent stages.
So the National Framework for Climate Services will basically be an interministerial or interdepartmental way of looking at climate services. At the moment, there are various agencies which function as per their ministries. It could be the Central Water Commission or the India Meteorological Department or various stakeholders. But with the coming up of this proposed framework, it could be a platform where there is more interaction between users, sectors, and everybody who use climate services. It's going to be a common platform.
Now, while most people would typically associate the IMD with its daily weather predictions, the Weather Department's new framework will focus on the collection and dissemination of long-term data on climate change. Anjali explains with the help of two simple analogies.
For example, the fisherman community, they would want to know whether they can continue to remain in the business, say, the next 30 years. What if the river or the sea where they are commonly going fishing is expected to see lesser amount of fish in that area? So is it sustainable for them to continue? Or it could be the renewable energy sector. I'm planning to install solar parks or wind parks. If there is going to be some change in the wind pattern in the, say, next 30 years, 50 years, is it feasible? So it's more of a long-term policy and planning for that purpose. It is not for immediate weather events, but it is more for long-term planning purpose. And for that, we need to know how the weather has changed over the years. We need to have climatological information in order to bring up such kind of a climate service and a national framework.
In this segment, Anjali Marar joins us to tell us some more about the framework and how it will work. So Anjali, how significant is India's decision to launch this framework?
So everybody is possibly being affected by the weather vagaries or the extremes that we experience during our, the recent years. It could be sudden heavy rainfall and flooding, or there is excess of heat and we're not able to bear it. So these are all some signs of the possible changing weather and overall effects of global warming. So in order to be prepared towards the more likely scenario of a rise in extreme events as suggested and proposed by several studies, we need to know how we should prepare, how India as a country should prepare in the next 30, 50 or a long-term basis. If we are able to predict how the climate can be based on the climatological information or based on the observations that we have so far, it will be better for preparedness for a country as a whole. And for that, we require climatological information. So at present, India Meteorological Department, which will soon enter its 150th year, they have information from large parts of India, but there are gap areas wherein suppose our oceans are not well documented, Himalayan regions are not well documented. So these gaps could create some trouble, create some problem in making the long-term climate predictions. So with this framework, it is also envisioned that there would be better observatories, better number of data coming in, and which eventually will help bring together all the sectors and have a common platform for the stakeholders and climate users to interact and use the information.
Right. And this particular framework is based on an existing framework, right? The Global Framework for Climate Services, or GFCS. So could you talk about that a bit and how the NFSC builds on that?
Right. So national framework is typically for every country. For example, India will adopt a national framework, but this is on the basis of a global framework for climate services, which has already been in place. So the GFCS was first introduced in 2009. And since then, there have been only 4 countries which have been able to go ahead and implement the national framework. The 5 pillars of the GFCS, if I may share here, are observation and monitoring, research, modeling and prediction, climate service information system, user interface platform, and finally capacity building. So these 5 pillars will also be followed by the national framework. And the global framework has also given us areas where the climate services can be first used. Some of these areas are agriculture and food security, energy, health, water, disaster risk reduction. So there is a global framework. Now it depends on every country to adopt the areas or adopt these 5 pillars and structure your framework depending on the requirement. For example, a tropical country like India, the needs will be different from a country near the northern hemisphere. So depending on every country's need, we can add sectors which are directly affected by weather and climate.
Right. And once this framework is in place, how exactly will these stakeholders use the data?
Right. So if a sector receives its relevant information, then possibly they can do a risk analysis, they can have some assessments, they can identify the vulnerable areas and make a long-term planning towards a sustainable development. This could be power sector, this could be tourism sector, so that they invest wisely. They are in a better planned and positioned manner using this climate information, which has been tailor-made for the sector.
You were listening to Three Things by the Indian Express. Today's show was edited and mixed by Suresh Pawar. It was written and produced by me, Rahel Philipose, Utsa, Sarmin and Shashank Bhargava. If you like the show, then do subscribe to us wherever you get your podcasts. You can also recommend the show to someone who you think will like it. Share it with a friend or someone in your family. It's the best way for people to get to know about us. You can also tweet us at Express Podcasts and write to us at podcasts@indianexpress.com.